You were literal days away from having to call up the regulators and say, look, we have to close down the business. That's not the position that I wanted to be in, but especially not with the founding team we had at the time, where I was not able to persuade them around the direction that I wanted to take the business, right? The most difficult and stressful thing about that period was actually whether I had support from within my own team, right? Literally the day when they called up, we were thinking, oh man, we've got about a month of runway. How do we manage this? It's happening again. And then I get this call and then I'm like, oh my God, we saved. Just absolutely incredible stuff.
Welcome to Space Terminal. Today, I'm joined by Taofiq Huq, founder of SpiralBlue. They build LIDAR technology for Earth observation. Earth observation dates back to 1946. What convinced you it was the right wedge today?
This is another one of these things from my childhood. I had, growing up, I had that passion for space, and I've also had a very strong connection to the environment when I was a kid as well. I'd go with my dad, I would go and do environmental volunteering. He used to run one of the biggest environmental volunteering networks in our state. And so every month or a couple times a month, I would go out, plant trees, pull up weeds, put on the gloves, handle very thorny bushes and try to pull them away to make sure habitats were safe for, native Australian animals and birds and plants. Right? And, throughout my life, I lost count, but I probably planted a couple thousand trees directly. And so bringing those two aspects of myself together, I realized when I was about 12 years old, like, how does this make any sense? My parents were agriculturists. I love space. I love building things and doing engineering. How does this make any sense at all, right? Until I realized at that age that, okay, hang on. If we want to do this crazy, amazing stuff in the future, build a future in space, we need to have a stable foundation here on Earth first. And to do that, we need to be able to measure and manage and build the right things here on Earth and then apply those learnings to space as well. And obviously it works the other way. Things that we build in space, we can apply those learnings to Earth. This is why I'd see, when I think of the future of, human civilization and the future of society, I don't necessarily see space and the environment as separate. I think if you talk about the environment, space is part of it, right? And so Earth observation made perfect sense when you think about it from a perspective of how can we use space to help better manage the Earth? And that's how we originally came to that. And so it was on literally on a treadmill one day. I was, in about 2017 when I was starting to think about what sort of, Earth observation technologies, kind of satellites could be built. What would the ultimate future in Earth observation look like? And yeah, that was, it was an interesting time because it was around the time of the IAC in Adelaide as well, here in Australia, where I had the fortune of seeing Elon Musk live talk about his plans with, what would become Starship, right? And so having that inspiration, seeing what was becoming possible in this industry, it wasn't just a matter of space agencies and very large companies, it was actually startups were starting to come to the fore as well, really made me think that, okay, yeah, we could get into Earth observation and we could get into it from a perspective of building it ourselves.
Why LIDAR? There are so many other types of remote sensor technologies. Why did you reject the alternative?
We do not reject the alternatives, right? Because ultimately for customers that need insights and reports and analytics, it's a cost center. If they could use free data, they would, right? And so we came at it from that perspective initially of, okay, what is possible with free data? Then what was possible with very low cost data from Planet and other providers? And eventually we realized that, well, no, in a lot of cases, the requirements that customers have are so, high resolution or very high revisit rate, you need to refreshes constantly. We just realized that, well, okay, yeah, the free stuff and the low-cost stuff wasn't cutting it. And so, but LiDAR specifically, I'd actually ruled out LiDAR as a technology that we would work on, right? Because it just seemed, oh man, giant lasers in space, that seems really power intensive. Is that even possible, right? And I read up some of the literature around JEDI and ISAT-2, which are the major NASA missions that are doing LiDAR in space. And so I was like, okay, yeah, this is possible. But, if we scale this up, we're going to need a satellite the size of the International Space Station, right? In order to have not necessarily at scale measurement, but just something that, customers could be interested in, right? And at that time, I was not yet aware of just how far the advancements had gone in LiDAR tech through, things like self-driving cars and whatnot. We were actually pulled at it from the other perspective, from a customer pull perspective, where we were working across the Earth observation sector in areas such as, flood management, in areas such as carbon farming, so carbon capture in forests. And it was really that carbon capture in forests angle where we had some clients come to us and basically say, Taofiq, we're planting all these trees, we're collecting carbon credits from the environment, it's a great business for us. But there's always that regulatory and auditing risk that, the government could come to us and, we're not 100% confident that, even though we're massively discounting the amount of credits, the amount of carbon that we're capturing and thus the revenue we're making, there's still a risk that we could be audited. We could still come in far below what we're actually expecting, in which case that's a massive financial risk for us. And so they wanted better data sets, better machine learning models and AI models to be able to handle those data sets to produce more accurate predictions on carbon volumes and carbon flux, the amount of, the rate at which carbon is changing in the assets that they were managing. And so we came at it from a perspective of, again, like, can we start with the free stuff? If not, then, how far do we need to go? And basically, we looked at synthetic aperture radar. We looked at the highest resolution electro-optical imagery. We looked at even things like hyperspectral and, very frontier technologies. And it just was not cutting it in any way, shape or form, right? They still had to send people to the site to take measurements there. They still had to fly drones and aircraft around to capture, unsurprisingly, LIDAR, to give themselves the highest accuracy that they could. But it just wasn't economically feasible to do it over their entire site. And so as a result, they were capturing maybe less than a percent of the areas that they were managing using those actually most accurate remote sensing techniques. And so when we thought, oh, maybe we could use, the small amounts of LiDAR that we're capturing, apply kind of sampling technique, classic, machine learning model approach, where you say, okay, let's take the area that's covered with LiDAR, compare electro-optical and other types of data with it, and then extrapolate out from there. And there's a lot of research out there that claims very high accuracy. We went really far with this, and we, looked at it from a perspective of we want to achieve the best possible outcome for the customer. And so on a site basis, if you applied it to that site, the accuracy was decent. If you tried to generalize it, the accuracy drops to the range of about 50%, which basically you're flipping a coin at that point in terms of how sure you are around how much carbon is actually stored in that forest. And so we went to them and said, look, existing data sets, yes, it's affordable. Yes, they can be scaled across, millions of acres. But ultimately, we're going to need LiDAR, and we're going to need ways to scale that LiDAR across those very large, very remote assets. And so we came to a conclusion that, well, maybe LiDAR in space is worth investigating. And that's when we started to see that actually, yeah, there is some technology push that's happening in this realm as well. And that's when it really started to come together. That was in the roughly 2023 timeframe that we really started looking into that.
Prior to that, you had pitched edge compute, and then you rebuilt to LiDAR. What broke in between?
That's a really interesting story. So we started the company with a focus on how can we get high quality, high revisit rate Earth observation, not just for, defense and government, but for potentially ordinary people as well, for farmers, for people dealing with natural disasters, for insurance companies, for all sorts of commercial entities. And so one of the bottlenecks that we highlighted, and the reason we came to edge computing was, could we better manage the huge amounts of data that were coming out of these satellites, expand the capacity that they were limited by at that time, and be able to bring down insights rather than just raw data, and be able to do it much, much faster than you would normally be able to take that raw data, process it, disseminate it, put it into reports. The ambition had always been that was going to be a bridge for us to building our own missions where we could have really strong impact on multiple sectors all over the globe, right? The goal for us was never to actually just become a component supplier. But at that time, there were a few things that broke. One thing that did break was there were a lot of delays in some of the grants that were coming through at a federal level here in Australia. There was a change of government at that time. And so, far be it from me to denounce the government or anything. I think they were being a bit careful with the investments that they were wanting to make, especially since at that time we were dealing with a lot of inflation in Australia as well as internationally. But so I know where they were coming from. But as a result, there were a ton of space companies in Australia that actually went out of business in that time. And we were able to survive thanks to initially building that business with edge computing, where we started to supply components. We started to win analytics contracts and satellite image resale contracts in the Earth observation sector as well. And we managed to bootstrap the business and keep it going even without raising any institutional capital or anything. But that was a very traumatic time for the business. And it was actually at a time where we then had that, decision point in front of us of, do we take a bit more risk and try to really focus in on a potential mission that we could build where we essentially verticalize, we work with the clients and we also have our own satellites? Or do we build this, safer business where we just focus on, services contracts, we focus on components, this kind of thing. And so this was a massive debate between myself and my co-founders at the time. I had come in very much with an ambition of, we need to generate impact and we need to own that impact, right? We don't want to just be helping other people with their missions. We need to be doing our own missions if we want to really push, potential impact that could be made in this sector. And if again, talking about building the future, it's one thing to go to someone that's already doing it and, to say, do you need help? It's another thing to lead the charge ourselves. My co-founders didn't come at it from that perspective. They saw a pathway to a sustainable business. And so we decided to split ways in late 2023. And that time I actually took a little bit of a sabbatical and started to really investigate, actually full time, could we make this LiDAR from space business work, right? And so I actually spun out some of the intellectual property that I developed around LiDAR in space at that time. And so it was in early 2024 that, as the two businesses were kind of operating, we came to further disagreements because of the structure of the ownership of the original company, Spiral Blue. And we were not ultimately able to agree on a price at which I would be able to exit the company that they would be happy at as well. And so ultimately we came to the decision to split the company in a different way, where I would take back control of Spiral Blue, we would buy out my co-founders, and then we would allow them to keep operating the edge computing and services businesses, but through their own business rather than through the Spiral Blue brand. And so that was a very difficult series of conversations. And it's something that I wanted to highlight because I don't think people talk enough about the biggest risk that happens with startups and the biggest failure mode. And that really is co-founder dynamics, right? In our case, we weren't able to make our first founding team work. But, when I came back into Spiral Blue in early 2024, I brought in MJ, actually my life partner as well, right? So I had already been having her support for a number of years as advisor to Spiral Blue. And so I realized, well, this is, it's a good working relationship already. Let's take further advantage of that and let's work together. And she was very excited to do that, especially as she recognized, she didn't come from the space industry, but, she was from Bangladesh. She had been through the flooding and natural disasters there. She saw firsthand what not having the right data sets can mean in terms of depressing economic opportunity. And so she was immediately, as soon as I asked, she was immediately in, right? No questions asked. And, it was basically the two of us when we went back into Spiral Blue, and we basically built the business, completely recapitalized the business, which was a hell of a process, let me tell you. We actually didn't complete that until we were in the middle of the Techstars Space Accelerator program where you and I actually originally met. So you can imagine going through all of the stress of the recapitalization, of the, going back and forth with lawyers and advisors around, how do we make this happen? This dispute has come up. How do we manage that? And then also having the stress of, the Techstars program where, we need to be pitching to as many customers as possible. We need to be pitching investors. We need to be pushing the technology, and we need to be getting ready for demo day, right? And that was a real stress test where I can say it was a difficult time between me and MJ, right? But we made it work. Right. I could not be more proud of her and obviously of myself as well for managing to navigate that period. But yeah, that's how we refocused the business, pivoted from edge computing to now doing LIDAR in space for Earth observation. And that's how we rebuilt the founding team and recapitalized the company.
It sounds like a moment where you doubted the future of Spiral Blue. What changed the trajectory, and what does failure mean to you?
So it's interesting. It was actually before we did the pivot that I had the most doubts about the company. And I think it again speaks to the factor of if you have the right people around you, anything becomes possible. When when there was those delays with government grants, for example, huge financial pressures on us, there were multiple times when we were literal days away from having to call up the regulators and say, look, we have to close down the business. That's not the position that I wanted to be in. But especially not the position I wanted to be in with the founding team we had at the time, where I was not able to persuade them around the direction that I wanted to take the business, right? And so that was, when I look back, it's not actually being on the edge of, having to close down the business. That was the most difficult and stressful thing about that period. It was actually whether I had support from within my own team, right? And so when things changed, it's not like we went through Techstars and we got a huge amount of money. There's a very small nominal investment that they do. It's certainly not enough to give us years and years of runway. And so when we finished at Techstars, we still had the same financial pressures. We had to go out and find clients. We had to find ways of keeping the company running. And again, there were periods where we were very, very close to having to call up regulators and say, look, we can't do this anymore. We had the support, MJ and I supported each other. We got through that period. And I'm proud to say that we managed to keep things running to the point of winning 3 million Australian dollars, so just over 2 million US in non-dilutive funding from the Australian government. Again, multiple periods in that time. Literally, the day when they called up, we were thinking, oh man, we've got about a month of runway. How do we manage this? It's happening again, literally having that conversation. And then I get this call and then I'm like, oh my God, we saved. Just absolutely incredible stuff.
Space values the Earth observation market in 2024 as $5 billion. You are trying to capture, for example, a quarter of this market. What is stymieing that advancement?
Valuing the Earth observation market is so difficult, right? It's kind of like, because there's so many things reliant on it at different levels. that you can start to, if you start putting the numbers together around how much value add to global GDP the Earth observation market has, you can measure it in the trillions of dollars. But then if you try to understand, okay, what is the actual commercial market? If we go into business, how much could we charge? All this kind of stuff. The numbers start to look very, very small. And that's a function of the fact that clients don't care about the data. They care about what does that report look like at the end of the day? What does that decision point look like as let's say a landowner, or as an infrastructure operator, or as a bank or an insurance company or similar? If I'm not able to go out and collect that data myself from existing open data sets or from historical data, I don't really want to pay that much for it, right? Which is where then it starts to change. And I think we've seen that with companies like LIDAR that have really focused on what is one application that we can really deliver a huge amount of value to customers for. And so at that point, the data, no one cares about the data. What people are caring about is, oh, you're helping my infrastructure assets become more resilient to climate change, more resilient to natural disasters. You're helping me reduce the potential safety impacts of having to send workers on site and do maintenance and do inspections and things like this. You're essentially adding revenue, you're reducing costs, and you're massively reducing risk and compliance issues as well. When you start really honing in on, okay, what does not the geospatial team, no one cares about the geospatial team. It's usually just seen as a cost center, a bunch of nodes that, work with maps. No one really cares about them, until that team is able to give them that report that says, this is how you make a ton of money, right? Or this is how you reduce a ton of risk. And so we as a company need to be doing, that's exactly what we as a company need to be doing. We need to be looking at, what companies like LiveEO are doing. And I think what a lot of AI companies are doing as well. I think there's a very strong overlap versus AI companies. We don't classify ourselves in the AI sector, even though we capture huge amounts of data that is ultimately then used for machine learning and AI applications. But yeah, it's the same kind of thing. What is that ultimate recommendation that can be produced, and what is the value of that recommendation?
What prevents you from 10xing your customer base over the next 1 year?
It is very much supply. We are looking at a drone program where we will work with local partners to help them get in front of more customers who may not necessarily be able to afford or operate drone LiDAR today. The biggest blockers to that has always been, if you're operating a drone company, you need to be very cognizant of things like transport costs, paying your pilots, safety, regulations, all these kind of things, right? I think because we are coming at it from a perspective of, we want to work with drone companies, and we want to work with them for clients that need that really extreme details of data, right? To the point where you can see individual leaves on trees, right? That's the point at which some clients are at. But in a lot of cases, the clients, if they get that data, they can average them out over a 1 meter resolution. We are looking for those clients for our future Earth observation satellite constellation. And so there are those partnerships we can build with local drone companies all over Australia and all over the world to initially start accessing revenue. And that's what we started doing. But in terms of going much, much further, you talk about 10x, I'm thinking about that 100x or that 1000x, right? We really do need to get satellites on orbit for that. Now, that said, there are options, and this is what LiveEO has started doing. There are options for using existing satellites in specific ways, using techniques like stereoscopic imaging and whatnot, that start to produce products that are not quite at the level that we need for a lot of our clients, but it might be a good way to get in, for example, right? And that could be an opportunity for us to, 10x our revenue in the next 1 to 2 years. And that is something that we are actively working on. How do we build those products? How do we find the right clients for those products? And make sure that we're delivering in a way that's not poor quality, or in a way where we deliver, we deliver. I think that's a really understated part of the Earth observation sector, where unlike communication satellites, for example, you don't just put up an Earth observation satellite and immediately start making money. You need to make sure that the data that you're collecting is calibrated, validated, tested against ground points, all these kind of things. So that's something that we're really looking at to make sure that when we deliver to a customer, we're not immediately burning them because we're essentially shoveling mud into their driveway.
You've mentioned working with UAV partners, drone partners, but also with carbon farming partners. Today, how easy is it to go live? Is it something that needs to be calibrated per customer? Is it standardized?
So at the moment, it is very bespoke for a lot of customers, very different types of land that they work on. There's one client I can talk about where they had another company that came in and did the work for them. I think that company went out of business. The work that previous company had done, there were a lot of issues, and we had to go in and fix those issues, right? We are having to do very hand-in-glove support for that client, but we are working towards how can we make this repeatable, being able to help the client to come in, standardize everything to the point that they can essentially sign up, click a button, put in some points around their property, and immediately get a report that they can then turn over to regulators and start earning money through the Australian carbon credit units market, right? We're building the software for that right now in partnership with our client.
90% of LiDAR components are Chinese APDs. Is this a supply chain risk or is it a non-issue?
It is 100% a supply chain risk. We are able to get by with European and US components. We are having to be very, very careful though, because in a lot of cases, even those European and US components, the subcomponents in those are sourced from China as well. And so it's always a risk. When you look at the trust that we've had Western countries to put essentially our entire supply chains into China, it does worry me, especially given just the way things are trending at the moment. But it is 100% a risk, but it is something that we are going into eyes wide open and making sure we are reducing that risk as much as possible.
The argument around edge compute is that it reduces latency. However, legacy infrastructure is built around data downlinks. So how do you process your data and what shifts have you seen recently?
So something we're actually developing internally. I think this is the classic, being on the bleeding edge of a market, you realize things that in years in advance of when customers realize things, right? When we started working on edge computing, I had to tell everyone exactly how it worked, why it would be beneficial, all these kind of things, right? And there was a switch in maybe 2023, roughly, when I went to conferences and suddenly people were pitching my own company back at me, not because they were competing with us, but because they had picked up that understanding from the broader market around the value of what we were doing, right? Now, what we're actually doing with edge computing is we're going an entire level further, where we're talking about, can we create autonomous processes in satellites to massively reduce the operational overhead needed to operate satellites and achieve quite significant efficiencies, for example, in power usage. And power usage is obviously the big one for us working in LiDAR. So for example, using our edge computing technology, we found a technique that allows us to reduce the orbit average power of our LiDAR by almost a factor of 10, which, considering power is the biggest issue for LiDAR satellites for Earth observation, that's obviously a pretty handy little breakthrough that we've had. So I think obviously there are now companies that are starting to do in-space robotics, that are starting to do servicing, assembly and manufacture in space, starting to do rendezvous and proximity operations. And right now, a lot of that is very manual. You have teams of people sitting around in operations centers, classic, think of Houston, right? You have 100 people sitting around watching monitors for each, like 3 variables, because, you still need that human factor to be really responsible if something goes wrong, right? And you need to essentially babysit an entire system for hours and hours and hours to do something that if someone was there in person, they could just be like, oh, yep, I just press 3 buttons and it works, right? So that is the situation right now. But I think we are very rapidly approaching a number of breakthroughs where you can start to use edge computing on board to reduce the latency, not for getting data back to the ground, but actually to reduce latency around decisions in orbit and achieve autonomy, or at least autonomy to the point where instead of needing 100 people to operate a complex system, you might only need 2 or 3.
Rank these variables from 1 to 4. 4 means it's mission critical in 2026. Thermal management.
4.
Data bandwidth.
3.
Radiation hardening.
2.
Let's dig into thermal management. I've spoken to a handful of founders and they're very excited about using sun as a source for ubiquitous energy. So why is power still a risk for you in 2026?
So for us, it's a bit of a flip in perspective, where if we did not have our technology, that would mean we have essentially 10 times less capacity to generate revenue on the same size of satellite. So this technology doesn't reduce peak power, right? In order to, for example, penetrate forests, see what's happening on the ground, we still need to, output a ton of power into that forest column. But in terms of what we're able to do operationally to map large areas and things like clouds and water and objects where we're not interested, that's really where that technology starts to come in. And that's really where, because we're able to do that, we can expand the capacity of our mission and start to deliver lower cost data with better revisit rates using the same size of satellite. So I actually look at it from that perspective, that it opens for us a much larger potential revenue using still relatively small satellites. But to come back to your point on thermal, we have our own ambitions around building essentially satellites that could be deployed on Starship, not necessarily taking a full launch, right? Maybe we could slot in If you've seen some of the renders around Starlink satellites will be deploying out of Starship in the future, sort of popping out like a Pez dispenser, you could imagine that they could fit commercial satellites in that stack as well. In which case, we'd love to obviously build satellites to that form factor. And having done some initial, very rough designs around what that may look like, the numbers are staggering, right? If we build a 250 kilogram satellite that can, reach the ground, cover relatively large swaths of land using LIDAR, the payback period that we look at for that satellite is about 7 months. Obviously all the programmatic costs, if we put that all up front, we take away, things like R&D costs, which will be spread across multiple satellites. It works out to the amount of capacity that is available should bring us to break even on that initial investment within 7 months, right? Which is, obviously, if you're able to do that for any investment, you'll be a very happy investor. For this class of satellite that we could put on Starship, where we could have, 25 wide solar panels, where we could have much larger optics, and because the size of the satellite is much smaller, fly at a much lower altitude in VLEO, which means for us, because the amount of power you need for LiDAR in order to close the range equation decreases at the square of the distance. That means if we get twice as close, we need 4 times less power. You put all of those factors together, and suddenly you're looking at a satellite that doesn't repay for itself in 7 months, not in 7 weeks, but in 7 days. At which point you're like, what? Can we even find enough customers for the satellite in that period of time, right? Or maybe we need to look at, do we improve the resolution or do we reduce costs? The economics start to break down, right? Because it's like a singularity in a way, not in the classic, AI sense, but in the sense of the possibilities of what become, what can happen with that class of satellite on that launch vehicle just start to become so ridiculous that we need to rethink the entire business and how it would work once we're ready to get to that point. And so if we talk about that satellite, 300 square meters of solar panel, roughly, we would be dealing with probably about 20 to 30 kilowatts of, orbit average power, of which about half to a third would be dedicated for the LiDAR. That is a lot of heat that we need to manage, right? And so if we're talking about managing that heat, we need deployable radiators, a very well understood technology, and the only way, in fact, to lose heat at scale in space, right? There's no air, there's no water in space to magically take heat away, conduct it away. You need to radiate it away through the black body effect. And so what that means is either we try to make very large radiators that operate at low temperatures, or we make small radiators that operate at high temperatures. And so then that leads to a very complex, if you take a high temperature radiator approach, it leads to a very complex thermal management scheme where you're trying to draw heat away from very low temperature components such as the optics, such as the detectors. You're trying to draw heat away from high temperature components such as lasers and computing and the other subsystems in the satellite. But then somehow you're doing that and you're putting it into a system that is actually higher temperature. So it almost operates backwards. Normally in a thermal management system, the source of the heat is the highest temperature thing on that system, and then the way that you get rid of it is you pump it to somewhere that's lower temperature. So we actually need to do the opposite, where we actually pump heat up, levels to higher temperature systems over time. And so it's a really fascinating series of engineering questions that we're actually looking to get some people on board, and we have some university partnerships here in Sydney where we're starting to look into how can we do that. How can we build, for example, topographically optimized 3D printed structures that can natively handle these kinds of systems and do it in a far more efficient way, right, while still coming in at a much lower cost. And so it's like we're building a gigantic industrial fridge in space to manage all of our heat in parallel to a system that has a bunch of gigantic space lasers and a Hubble Space Telescope sized primary optic, right? It's just, and obviously the 30-meter long solar wings, like you can't forget that. Hopefully we can get some renders for that system that we're starting to put up on this podcast. So yeah, it's just absolutely ridiculous stuff. And I am personally not expecting to start working on it in earnest tomorrow, but we are getting ready to seriously talk about it and, what that may look like from a budgetary standpoint in terms of raising the money to build it, and what would be needed from a technological standpoint as well to actually build it at scale. And ideally not just one, but potentially 10 or 100 or more. So we can then provide LiDAR from space, not just for a small number of assets here and there, not just for defense and government clients, but for commercial clients as well, the carbon credit sector, insurance, agriculture, and sectors such as banking even potentially, where we could provide very regular updates on what is happening in the middle of a natural disaster, which with LiDAR at the moment is just not possible, right? You have to get planes over there, you have to get drones, it's just not possible.
There's SAR, there's LIDAR, optical, hyperspectral, handful of remote sensing technologies. What is the cost for actually mapping, for example, this hectare of forest? And why would a company pick LIDAR over alternatives?
Let's look at it from existing remote sensing Earth observation providers, right? Optical data, the pricing for that is very well known. Mantle, they're very much at the premium range because they have the highest quality data, of course. They can come in anywhere from $30 to $50 per square kilometer. Lower cost providers such as Planet, Black Sky, Satellogic, come in between that sort of $5 to $20 per square kilometer range. And so, this is quite affordable data. If you start looking at synthetic aperture radar, pricing for that is a little bit more opaque because they do deal more with defense and less with commercial. So they don't necessarily publish their price lists in the same way. And then there's also the fact that this is a massive advantage that SAR does have, is that they can do those very medium resolution, very large swath captures. And then they can also do focused captures where they improve the resolution as well. And so I'm sure they've got a very complex pricing table in some software that they operate when they're speaking with clients, and so I can't speak around that. But obviously, the pricing I would expect would be a little bit more premium than optical because SAR is able to see through clouds and it does work at night, so it's a better product in some ways. But it is also a more difficult product to analyze because with optical you can just look at it. Right? You can create inferences, expert level human inferences if you just put a random person in front of a satellite image, they'll know pretty much what's going on if they zoom into it and look at it, right? With SAR, there's probably only a few hundred or a few thousand people in the world who natively have the ability to look at a SAR image and know exactly what's going on just with a glance. And then if you think about, well, okay, those people then have to build machine learning algorithms based on their expertise. It's very, very difficult. And so as a result, it's not easy to work with SAR data for that reason. But still, the insights you can draw from it are fantastic. So yeah, it gets a similar sort of cost level to optical. With Hyperspectral, I think providers are trying to provide it at a lower cost for larger captures, which is interesting because Hyperspectral is in many ways a much richer data set than optical, and it's actually harder to capture, right? Even though you're reducing the resolution, you have potentially, let's say you're reducing the resolution from 1 meter to 30 meters, right? You're saying, okay, it's going to be 900 times the area of, the pixel is going to be 900 times the area. But then if you're capturing 1,000 bands of data, that means you're essentially taking that one pixel, dividing it by 1,000 times, which reduces the amount of light that you have to work with to create a really clear signal, right? And so if you think about it from this perspective, from a signal to noise perspective, if you have a certain signal to noise ratio that you're comfortable with, if you then have to divide that light signal by 1,000 times, you're not going to have a very good signal to noise, right? Which means you need to increase your signal, you need bigger optics, you need bigger satellites, right? So I actually do think that Hyperspectral is a more premium product than optical and synthetic aperture radar, but obviously you have to make some decisions if you want to win clients over to a very new type of data set, right? LIDAR is interesting in this realm. It is an active sensor similar to SAR, and so it is more difficult to collect. And so as a result, what we have seen in the market is LIDAR, especially the points of comparison are mainly with drone companies and with aerial companies that have to fly bespoke assets or drive out to locations, create filings with regulatory agencies to do this kind of thing. And so it ends up being a very expensive mission that you carry. And so the pricing for LiDAR is usually done on a per hectare basis. So a hectare, for people who may not be aware, because it's a very farming term, right? You usually think of in terms of hectares, not square kilometers. A hectare is about 2.5 acres. And if you were to break a square kilometer into hectares, there's about 100 hectares per square kilometer. So just for the sake of comparison. So from that perspective, you cannot buy a satellite image per hectare because the pricing would be so low that it would be laughable, right? A $10 per square kilometer image would imply a 10 cents per hectare image, which no provider would be willing to sell at such a low cost. If we come to LiDAR and we look at the pricing that's done, because it is done on a per hectare basis, I'll convert it to square kilometers just so we stay consistent. But usually we'd be doing this on a per hectare basis. So quadcopter type drone LiDARs can be in the high hundreds to low thousands per hectare. And so that means tens of thousands of dollars per square kilometer, right? It's just really not doable, right? The only reason you would do that is if you had a very small property, a few hectares in size, you could get someone to drive over for a couple $1,000 or a few $100, and they'd be willing to map that out for you and give you that data set, right? Certainly, if you tried to buy a satellite image of that property, you would be asked to buy a 100 square kilometer image, in which case you'd be paying about the same amount of money, if not more, and you'd get a far less detailed product. Which is why, that kind of equation makes sense. Why you'd want to bring someone over with a drone to fly around, even absorbing such high, initial fixed costs. If you were then to try to scale that up a little bit further with, let's say, fixed wing drones, which have much more range, and can operate beyond line of sight in a much safer way compared to quadcopters, where, if a quadcopter fails, it just sort of falls out of the sky and, it might fall on someone's head, which is really the risk that regulators look at. Whereas with fixed-wing drones, it's an aircraft, right? Like it's a winged aircraft. So if it fails, if the propulsion fails, it can still safely guide itself down to a soft landing, right? That's really the benefit. And so as a result of that, you can operate beyond line of sight, and the cost for that LiDAR, which will be a little less detailed than the quadcopter LiDAR, because you're not staying over an area. You're flying very quickly, like 100 kilometers per hour, 100 miles per hour or faster, right? So you're not getting as detailed data. That pricing can be in the high tens to low hundreds of dollars per hectare. So multiplying that out per square kilometer, $5,000 to $10,000 per square kilometer still, right? So still very expensive stuff. If you scale that out to much larger areas, then you can start to drop that cost to the low thousands per square kilometer, right? So it's still very expensive. But again, if you have a small property, that could be your only option. Then if you start looking at aerial is really, really interesting, because aerial can reach remote areas, but they're not going to be willing to get to those remote areas unless you give them a project of sufficient size, right? So the typical minimum size or minimum project size that an aerial company would look at would be in the tens of thousands of dollars. But they would be willing to map out hundreds of square kilometers for you in a project of that size, if they're not traveling too far. Obviously, if they have to cross half the country to get to you, they're going to charge you more for that. So what that looks like is they come in anywhere from about $1,000 per square kilometer to about $300 per square kilometer. And so still, more than 10 times more expensive than optical data or other types of satellite-based data, right? And so it's just that the economics of it are much, much more difficult for buyers to absorb than for satellite imagery. What we're doing is we're looking to bring in quite a steep discount to what's possible with aerial. Now, obviously, we're much, much higher up, hundreds of kilometers up in space. We're not going to reach the same level of resolution as aerial, right? Aerial companies nowadays, very commonly, they're at anywhere between 50 centimeter resolution to about 20 centimeter resolution, which for people who are listening in who know about LiDAR, I should be speaking about it, points per square meter type metric, but I'm going to simplify for people who come at it from a optical, or Earth observation standpoint. So I'm going to be talking about in resolution. These are not the same numbers, by the way. That you can't quite directly compare them, but I'm just doing it for the sake of simplicity. Yeah, that 50 to 20 centimeter resolution is typical for aircraft nowadays. We would be looking to come in at about a 1 meter resolution, or maybe slightly better than that. But we would be looking to come in at a very steep discount to what's possible with aerial, 70 to 90% discount to what's possible with aerial. And it's with those numbers that I talk about, having that 7-month payback period for, our first operational satellites, and then for that Starship-sized satellite, that's the kind of thing that we'd be charging, where we make our money back within 7 days, right? So that would be the point at which we need to seriously start thinking about, we need to drop those prices further, or much, much further, right? So it's a bit of a long answer, but hopefully I've given you a bit of a lay of the land in how that pricing is done. One thing I want to talk about is, we've talked about it from, this is the cost to the customer. I want to talk about it from the perspective of, well, why does the customer actually buy this in the first place, right? What is the business case for them? And so if we look at it from that perspective, it's actually quite interesting. I'll give you the detail you need to fully report, let's say, a carbon asset in the middle of the Australian outback, right? Where you might still want to do a few site visits just to be safe, but you can more or less get all the data that you need, right? And so some properties that we've been looking at, I won't speak in exact details, but they can earn up to about $100 per hectare per year, through carbon credits. So if we say that in square kilometers, that's about $1,000 per square kilometer per year. If you need to charge for aerial hundreds of dollars per square kilometer, that's a very difficult proposition to make. Right? It's still a positive ROI, but it's a tight ROI, right? It's at a point where it's like kind of risky. You're not sure if you want to make that investment. On the other hand, where the level that we're coming in, where we could be at $100 per square kilometer, or maybe lower, you're talking about a 10 times return on that purchase. So I think we're coming in at a price point where, for customers, it's much more comfortable that, yeah, sure, we're taking a risk, but there will be a really solid return.
1 hectare is 2 to 3 football fields, just for reference. So that's a lot. How does Spiral Blue become profitable at scale? Yeah. Talk to me about profitability. How does Spiral Blue become profitable at scale?
Profitability at scale for us looks like having sufficient capacity that we can deliver satellite-based LiDAR to anywhere in the world within a day or less. That's really what we're looking at. For long-term profitability. In terms of short-term profitability, I do believe the first operational satellite mission that we launch will be profitable. I mean, it will, obviously, there'll be a lot of upfront costs, but I think as a net mission, it will be profitable. Now, that is a difficult thing to achieve in Earth observation. I can think of that one company that I reckon definitely achieved it, and that would be, Vantor, Maxar, originally, Digital Globe, GOI. They've had a lot of rebrands over the years, right? But the unit economics of our satellites look much more like the satellites that they build, even though our satellites are a bit smaller, at least initially, than what, for example, Planet or Black Sky are at, right? Where they really needed to build and launch constellations from day one. So we're coming at it from a perspective of, okay, we're going to start with a single satellite, deploy to a constellation over time, but that first satellite is going to be an incredible cash flow machine.
What should we look forward to from Spiral Blue over the next 3 months?
So one thing that it will be happening probably as this goes live is I'm going to be working with some customers that we have in the UK, in London actually, and we're going to be doing testing of with them in their labs. So, it's going to be going live at about that time. Shortly afterwards, there'll be some announcements around the outcomes of that testing and our relationship with that customer and around what we're doing for that customer in terms of their mission. So obviously I can't go into detail on that just yet, but it's going to be really exciting. So please keep an eye on LinkedIn. I have a Twitter as well, so please keep an eye out on our socials for more news around that. And in the meantime, we've been posting some hardware images showing off what we've been building and testing. If that's of interest, if you love to see space hardware being built from the earliest stage, give us a follow. I think you'll have a good time.
Last question. What's the best way for insurance, climate, defense partners to contact you or Spiral Blue?
Easiest way would be through our website, so spiralblue.space. Alternatively, I'm very active on LinkedIn as well as on Twitter, so please feel free to contact me through there as well. The name Taofiq Huq, that's my name on those platforms as well.
Perfect. This has been Space Terminal. I am Zuni from Imagining Forward. We have new episodes out every week. You can find Taofiq Huq and Spiral Blue in the show notes. You can also look them up on our intelligence tool at imaginingforward.space. Thank you for joining us, Taofiq.